Hello everyone, my name is Manoj and today I will be introducing my project on memory and arithmetic operations using 8051 assembly language. Assembly language programming is important because it allows us to control the computer hardware directly and perform tasks very efficiently. The 8051 microcontroller is widely used in embedded systems like automation and sensor based projects. With the assembly language, we can manage data in registers and memory and control input and output devices with a great precision. In our project, I focused on performing basic input-output operations and arithmetic tasks, especially addition, subtraction, and multiplication, and swapping using 8051 register. Learning these operations help us understand how embedded systems work inside and how we can make them faster and more reliable. Thank you for listening. And if you have any thank you.
Namaste everyone. My name is KM Kotresh from DS2A section. Today we will discuss about the objectives for our assignment. To design and implement a assembly programs for performing a memory and arithmetic operations on on the 8051 microcontroller. To understand the register level data transfer and manipulation in the CPU. To analyze program efficiency based on the instructions, count per execution, and memory access the patterns. To gain a practical experience of using Kali Mu Vision application for assembly level simulation and debugging the codes. Then next, go through problem statement. We have a four problem statement for our assignment. First, swapping contents of two memory locations. Memory locations means we have to swap the one number A to B or B to A, exchange data using the registers. Next program is adding the two numbers 32H and 33H. We are given the specific values to the program. Store a result at 34H. We have a 32H and 33H numbers and then result is stored at 33 heads. Next program is subtraction of two numbers. We have a numbers or values 35 heads and 36 heads. Store result at 37 heads. Next multiplication of two numbers. We have a values 38 heads and 39 heads. In multiplication of two numbers, store a 16-bit result at a 34 heads and 38 heads. Thank you.
Hello everyone, once again Manoj here, and it's the program swapping two numbers locations. It is our first task in our project. The goal of the this program is to exchange or swap the data stored at memory locations 30H and 31 Hz. And these are the following steps to swap memory locations. First step, take the value from the 31H and put it on the accumulator or an temporary memory location. Take the value from 31H and put it on the register or not. Now use another register B as a auxiliary to help the swap the values. The values from 31H 30H, which is right now in the A, is stored in B as the backup. Move the value from R0 from 31H into the A and then store into the 30H. So 30H now gets the value of 30 from the 31H. Bring back the original 30H value from B into A and store it into the 31H. The final result will be like this. The values at the 31H and the 32H have been swapped. Next diagram. It is the sequence diagram. Uh, this shows the steps as the arrows between CPU and the memory. The CPU first reads the 30H into the A. It then gets the 31H into the R0 register. Then it saves A from the 30H into B as a temporary storage. Next, it makes a contain the value from R0 register, which was from the 31 hertz. The CPU then writes A back to the 30H. So now 30H has been 31's old value. Finally, it put the saved original value from A into B and writes it into 31H. The diagram usually shows the following steps. Shows data flowing from memory to register and back to the register. It is little bit confusing, but we have to understand it. And the summary of this uh, question is: this is the basic assembly program that swaps the data between two memory addresses. It uses registers and sequence of load and store operations to swap the values without using any data. Thank you.
Hello everyone. Once again here, KM Kutresh. The second task of our assignment is addition of two numbers. First of all, our aim is to add the two numbers. They are given memory locations 32 edge and 33 edge to store the result at 34 edge. First of all, you see the program. First of all, you see the algorithm of this program. First instruction is load the first number from 32 edge into a accumulator A for store a temporary value in A. Add the second number from 33 edge to A. Next, store the result at memory 34 edge. First of all, see the instruction clearly. Load the first number. The first number is stored at memory location 32 edge. We load it into the accumulator A using the instruction. See that program first line move A comma 32 edge. Next, second line. Add the second number. The second number is stored at 32 edge. We add it into the accumulator using a second second line of the program. Add A comma 33 edge. Next, store the result at 33H, 34H. After addition, the result will be in the accumulator A. We store it into memory location 34H using the program. See the program number, program line 4, program third line. Move 34H comma A. Store the result at 34H. After the program, we see the sequence diagram. Sequence diagram. In this sequence diagram, the CPU and memory communicate during the execution of addition of two numbers program. First, according to the first instruction, load the first number. The instruction move A comma 32H makes the CPU read the first number from memory location 32H and store it into the accumulator A. Next, second instruction. As per second instruction, the add A comma 33H tells the CPU to fetch the second number from memory to 33H. Then add it into the value already in A and keep the result in A. Next, see the third instruction. Using move 34H comma A, the CPU stores the result from accumulator into memory location at 34H. The sequence diagram clearly shows the step-by-step procedure of data flow. Thank you.
Hello everyone, I am Sharad KP. I am here to explain the subtraction of assembly program. The aim is to subtract two numbers. It has some algorithm like first one, load value from 35H into A, then subtract value of 36H from A, and then it stores the result at 37H. Next, the assembly language is shown in the document. First part, the org 0000H tells that assembler that the program starts at memory address 0000H. It just direct you from where execution begins. Next line, move a comma 35H. This instruction copies the value from internal RAM address 35H into the accumulator A. Next, the third line explains that it subtracts the value from the memory location 36H from the accumulator A, and it also subtract the carry flag if it is set. The next line tells move 37H A. It tells that this moves the result from the accumulator A to memory location 37H. That the end indicates the end of the program for the assembler. Next, the sequence diagram is the main part is CPU and the memory. In the move A35H, it moves to the 35H part, and the subtraction A36H means which subtracts the value. Move 37H and means it moves the value to the 37H. Thank you.
Hello everyone, my name is Prasan from the data science second year, and today I am going to explain an 8051 microcontroller assembly language program for the multiplication of 2-bit to 8-bit numbers. This program starts with the instruction org 0000H, which sets the beginning address of the code in memory. Then the first number is taken from the memory location 38H and loaded into register A using MOV A, 38H. Similarly, the second number is taken from memory location 39H and loaded into register B using move B, 39H. After loading both numbers, the instruction multiplication, that is MULAB, is used to multiply the contents of A and B. Since the result of multiplying two 8-bit numbers can be up to 16 bits, the lower byte of the result is stored automatically in a register A and the higher byte is stored in register B. Next, the instruction move 3AH, A stores the low byte of the result into memory location 3AH, comma uh, and uh, and move 3BH, B stores the high byte into 3BH. Finally, the end. The statement indicates the end of the program. And next, I am going to explain you about the sequence diagram. This is the sequence diagram for the multiplication of the two 8-bit numbers using 8051 microcontroller. The diagram shows the data transfer between the CPU and memory step by step. In the first step, the instruction move A, 38H is executed here. The CPU reads the first number stored at memory location 38H and loads it into register A. Similarly, the instruction move B, 39H reads the second number from memory location 39H and loads it into register B. Next, the instruction uh, multiplication AB performs the multiplication of the contents of A and B inside the CPU. The CPU uses both registers A and B for this operation. After multiplication, the low byte of the result is stored in A and the high byte is stored in B. Finally, the instruction move 3AH, A and move 3BH, B are executed. In these steps, the CPU writes the low byte of the result from A to memory location 3AH and the high byte of the result from B to 3BH. So overall, this sequence diagram clearly shows how data flows from memory to CPU for reading the multiplication of operation inside the CPU and then writing the result back to memory. Thank you everyone. And also these are the outputs of the addition, subtraction and multiplication and swapping two numbers. This is the first one is subtraction in the EDSIM51 software. It looks like this in the 8051 microcontroller, and this is the multiplication output, and this one is the addition, and this one here is the swapping. Thank you.
Once again, here I am Sharath here to explain conclusion part of our topic. In this program, we implemented a several 8051 assembly language program performing fundamental CPU operations such as data swapping, arithmetic problems like addition, subtraction, and multiplication. They are the key learnings: efficient use of accumulator A, B register, and general purpose register for data manipulation, understanding direct memory addressing and register operations. It reduces instruction count of optimal performance and a clear version of data flow between CPU and memory. The future scopes are extending these operations to array and sensor data array, implementing division, logical, and looping operations, interfacing with actual sensor via ports to process real-time data, optimizing instruction sequencing for time critical embedded system. Thank you everyone.